Hello everyone and welcome to another video from Yaw Games. In this one I'm going to talk about wall decoration. So after the last video in which I explained how I made all the wall generation, in the next thing that I wanted to do was decorate a bit the wall, as it's really plain. As you can see, it's just the blocks, the hills and the holes that you can find, but there's not much wall decoration in it. It's really flat. Let's decorate it with some normal trees for now. So how do we generate trees? At the beginning, I thought, well, the best thing and the easiest thing to generate trees is just randomly place them in any XY coordinates. But then I thought, well, I'm using noise already to generate a lot of stuff, so can I use it with noise? And the first idea was to basically, let's say that the highest, so ones and zeros, let's put trees on those places, so it will be kind of spread around, but it would be really random. Then I remember that one of the blogs that I was reading about wall generation actually explained how they place trees or how they decorate the world. So I decided to go back to that post and read it again, and let's see if I can implement that logic. So what they did is basically explain how to generate the height, which is what you see around here. Is we normally use red noise, which is high amplitude and low frequency, so we can see the curvature of the of the terrain. But to place objects into the wall, you normally use blue noise, which blue noise has high amplitude and high frequency, which means that basically you will have a lot of noise. It's not that fluent between minus ones and ones, so it will be much noisier. And then what they do is basically have a function which you check for a specific point if it's the highest on a specific radius. So basically you define a radius, which whatever value you want, and then you basically calculate, is this noise that I'm sampling is the highest around this radius? Yes, then that would become an object. And then you do the same thing for all the samples that you have for that specific blue noise that you are calculating. And the nice thing with that is that you can change the R, so you can have more amplitude between the objects that you place or less amplitude, so they are more clumped together, which would be nicer for example, in this plane to have more trees together, but in the desert, for example, have less of those objects together, because on the desert normally there will be less things, or whatever logic that you want to have if you want to change the R, which is not necessary. So let's see how this logic applies right now to this world. So at first glance, it's really nice. It's much more alive. The world, instead of feeling really plain, it feels real alive with all these trees, and it looks like a real world, more or less. Still, there are things that need to be polished, but it looks much better. So what I did is basically the logic that I explained before, and if you can check, I have different types of trees also. So I have this is the normal type of tree, then I have these tall trees, and then I have also, there are four, this other type of trees, and there's another one which is quite rare. So let's see if we find it, but I continue to explain what it's about. So basically, the way I'm generating the trees is, it's nothing fancy. I just have a base set of different types of trees, and depending on the noise value that I get on the sample, I will place one or the other. So that's the basic logic that I have for placing different types of trees. There's no fancy there, there's nothing different. This is not the most efficient way in which you can do this logic, because it means that each time I'm trying to sample these noises, I have to calculate, I have to check all the positions around the sample and see if it's the highest or not, and this I have to do it for all of these positions. So it's not as performance as other solutions. Which are the other solutions? So the other solutions are to use Poisson distribution, which is basically a random way in which to generate dots that are separated in an R position. So the same thing, you have an R, you have a set of points, and then you basically directly distribute them in the separation that you want to, instead of having to calculate if one sample is higher than the other samples around that specific sample. So why did I not use the other one, as it's more performance? Well, mainly because I didn't find any specific library that was fitting for me in the language that I'm using, which in this case is Go, because I'm using Eviten. So the next thing I wanted to work on to add more life into the world is add basically mob spawns, that some mobs will be able to spawn into the world around you. For that, it's still really early in development, but the logic that I follow, something similar to what Terraria and Minecraft have. So I read those two wikis and tried to make kind of a mismatch, something that would work for me. And the thing that I did at the end was this. So as you can see, the mobs are popping around. I removed the AI to basically pass to the player and so on. So this is just the first implementation and it's really, really raw. It's just placing random mobs in a mob cap into the world. So the logic that I plan to have right now is basically each wall tick, I will try to spawn a wall in the chunks. So if I'm going back a bit and I go back to the center, this is the kind of the full visible area. So I will try to spawn mobs into the chunk that I have here. Each chunk is 10 by 10. So here are basically 81 chunks. I will try to spawn mobs into those chunks and also basically filling the mob cap. And also there will be a chunk cap that you will not be able to surpass. And if there are less mobs on the total mob cap, it's more likely that the mob will spawn. So basically, when you have less of mobs, they will spawn more quickly. Also, mobs will not be able to spawn in specific areas. For example, you can see that in water they don't spawn. And also, mobs will not be able to spawn around the player itself. So for now, the logic that I will set is not set at this moment is that they will not be able to spawn around 10 blocks around the player, but once I start playing with it, I will see. So the other things that I want to check is that they cannot spawn, for example, in top of trees, which some of those are actually spawning on top of trees, which is something that I don't want to. And another part of the logic will be something that Minecraft has, which is spawn grouping. Basically, when a mob spawns, we'll have a chance to also spawn other mobs around it. So it will be like spawning XY coordinate, then in a specific radius from the center of that spawn. And if it can't spawn, then it will try to spawn another one up to 4, which is the maximum that I'm going to set for this pack spawning. And yeah, that's basically what I was working on this week. So the next week I will try to finish or at least have more of it on terms of the mob spawning. So yeah, thank you very much. Like and subscribe. Bye bye.